So, our last unit has 1 week until we're reviewing. It is on statistics. Okay, so we have this is our statistics unit. Basically, I'll just give you a quick definition. Statistics is just how to gather information and then how to study that information. That's all stats is. How to collect a bunch of different numbers or data, and then how to make assumptions or predictions based off of that data. It's helpful for a lot of stuff. You can become like a statistician in like a corporate, some big corporate, whatever, analyzing the data, dude, you're going to make 6 figures, just no problem. It's ridiculous. My college professor that taught us stats, worst teacher I ever met in my life, his name was his name was Dr. Cater. We called him Darth Cater because he was awful. And he made $115,000 teaching two classes. Because like statisticians didn't have much to do. You can imagine. Anyway, study as a college, make millions of dollars. Okay? But today we're just going to be talking about mostly how to describe the data once it's been collected. Okay? We'll do more of this for the days to come, and then we'll talk about how data is actually collected. Today is all about how to describe data already collected. There's 3 things we talk about. We talk about the measures of the center, measures of the shape, and measures of its spread. Okay, those are the 3 things. We break them down into different categories. So the first thing we're going to talk about is the measure of the center. Okay, it's called central tendency. And when we're talking about the center, that's usually where a majority of my data kind of revolves around. Okay, most of my data tends, usually, unless there's what's called outliers, usually tends to be around the center. There's 3 ways that we can give a description of the center, and they are 3 very common things that y'all have seen probably since like middle school. So I want to go through these kind of quick, but mean, median, mode. Okay, you might not have realized it when you're doing it in the past, but these 3 things describe the center of your data. Those numbers tend to describe its central tendency. Okay, what the numbers revolve around. Okay, we heard of these 3 things, right? Okay, so if I go through it too quick, you'll be like, hey, stop. I'm going to teach you how to do all these by hand again, and then later in the class, it's all done on the calculator. So everything in the calculator, everything. Okay. All right. So remember, mean is just adding the values up and then dividing by the total number of values that you have. Finding the average. And usually in like what's called a normal distribution, and we'll talk about what that means more later, but in a normal data set, your mean usually is in the center of your data, usually in the middle. That's usually how it works. Anyway, it says the high temperatures for a 7-day week during December in Chicago are those 7 numbers given. Find the mean. Just add them up and divide by how much you got. So let's do this together and make sure we can get through it kind of quick. I don't want to overdo it. Why am I listing them? I don't know. Yeah, we can just add them up. I don't know why I'm putting them in order. Yeah, add them just so I can at least write something down. Hey, add the 7 numbers and divide by what? You guys are smart. Somebody already do it. 33. So like if I get the mean, then I can make an assumption, say, majority of my data should be around 33 degrees. And that's kind of the idea of what the mean is. So, any questions on that? The next one, median. You've done this 1,000 times, I'm sure. But median means middle. Okay, median is the middle number. The number in the middle, if you put it in order from increasing or decreasing. Okay, so like smallest to largest or largest to smallest. And you find that middle number. Okay? Most everybody gets this right usually if you do it by hand. Especially if there's an odd number of values, y'all do great. It's just a number in the middle. But the only time I ever see people mess this up is if there's an even amount of numbers. Y'all forget sometimes to take the average of the 2 middle numbers. If you have like an even amount of numbers, and you go down to the last 2 middle numbers, okay, you don't just pick one, you add it. If you're going quick through all these problems, then you might mess that up. Okay. So looking at that last example, we got these 7 numbers. Let's just find the average real quick, the median real quick. You got to put it in order, smallest to largest. So help me here. 27, 28. 2 29s, 31, 32. That's ugly. Is that it? 35. Thank you. So I got 1, 2, 3, 4, 5, 6, 7 numbers, and how I do it by hand is I just go left, right, so I get kind of the middle number. And if there's an odd amount of numbers, it works out fine. So like 1, 1, 2, 2, 3, 3, and then you just circle the middle number, right? So 29. Now, in a perfect world, if this data is considered to be what's called a normal distribution, in a perfect world, the median and the mean would be the same thing. But because there is a fluctuation, there is outliers, like 55 is probably an outlier here. It tends to shift those data in different directions. And we'll talk about what that means later. But any questions on mean and median? Well, let's do another median, one with an even amount of numbers here, just to say we did it. It says the batting average for 10 members, so 10 numbers here, are given. It says find the median batting average. So help me put this in order because I always miss one since they're decimals. Let's do this. Is the smallest 0.198. Okay. The 0.2. I'm going to cross them off. Then what? 0.234. Point 240. Point 256. .276, thank you. 290, that does it with the twos at least, right? 0.3, 0.321, and 0.333. All right, ugly as crap, I know, but it's in order, small, large. Now, if you put them into order, small, largest, and you go through it kind of quick, sometimes you mess up and actually circle one you're not supposed to. Like, so if I go like 1, 1, 2 and 2, 3 and 3, 4 and 4, sometimes y'all go 5 and then circle this number, but just because you're going back and forth. If you have an even amount of numbers, we're down to the last two. You don't just pick one, you find the average of them. You know how to do that. You just add them together and divide by 2. We're literally finding the number in the middle of them. Okay? So whatever 0.256 plus 0.276 divided by 2 is 0.266. So that's your median. Questions on that? So mean, median, we've done that before, I'm sure. The last one for central tendency that is never used, I don't even know why I still teach it, it's not really helpful, I don't think. It's mode. Mode means most. Mode, most. It's just a number that occurs most often. And that really doesn't tell us any central tendency, so I don't know why I like to include that. Because, say you have 10 numbers, all that are different, but you have 2 numbers that are the same. What if those 2 numbers are just really extreme? To the right or left or something. That doesn't tell us anything about the center. So no mode, but it's just never used. So let's look at an example. Have we seen a extended leaf plot before? Y'all know what that is? Okay, great. Yeah. So a extended leaf plot is given here. It says Mrs. Smith's geometry used test scores, and what a stem does is the stem is the tens place usually. The right side is the single digit. So this is a 56. Right here is 56, or a 58, or a 59. That's just kind of how it's read. All the way up to looks like 2 100s. Is there a mode here? So, it looks like 95. 3 95s. I don't see any other number that occurs more than a 95. So in this case, 95 is the mode. And it's not the best central tendency because the idea behind it is that your central tendency, or your center, is where a majority of your data is at. So you would expect the mode to be in the center. But that's not always the case. So you can't really go off a mode that often. Okay, it's just not the best. But anyway, that's your mode. What if every value occurs only once? Do we have a mode? No. So it is possible for us to have no mode. All right, unless we have a single number that occurs more often than any other number, we don't have a mode. Okay, but we will always have a mean and median. So that's your center. That's how you describe center. Any questions about that at all? Any questions about the center? Okay. Now, with the center, you're actually going to do some math. The next one is all about really just identification. We're not really doing much math. We're just looking at some pictures and describing them. But measures of shape. Okay? So measures of shape describe how the graph looks, and it really talks about more of like where a majority of my data kind of like falls to the right, to the left, to the middle. That's kind of what it means. So if I'm describing its shape, I can do it in three categories. I can talk about it as symmetric, I can talk about it as left skewed, or right skewed. Okay? And the best way to show that and describe that is to use histograms. Okay, we're going to see this, especially tomorrow when we talk about, or Friday when we talk about normal distribution curves. What a histogram does is it tells you how often each value occurs. Let's say whatever data that we're looking at, the outcomes are 1, 2, 3, 4, 5, 6, and 7. So what this histogram is describing is that there's 6 is occurring most often, and like in this direction, that more high numbers are occurring than low numbers. Okay. And what we're going to learn is in data, for whatever reason, a majority of the data sets that we look at follow something that's called a normal distribution curve, meaning that a majority of your data is going to be in the middle, and then an equal distribution to the right and left. That's called a symmetric bell curve, because it looks like a bell and it's symmetric. Those who are taking stats, you know. But this shape right here, this is called symmetric. Turns out that in the middle here, where a majority of your data's at, that's also your mean. Okay? And then as you go to the left and right, farther away from it, it's going to be an equal amount of data. Like it's going to get smaller and smaller as you go away from the mean in both directions. Just measure. That's how it always works. But what happens is outliers are kind of thrown into the mix. Outliers are extreme values to the right or to the left that usually shouldn't be. They're like if you're looking at like the heights of adult bells in America, like you're looking at that data, and then you have like this super tall NBA star come out of nowhere, like he's an outlier. You don't see that often. Okay? They can skew your data. So like in this case here, if I kind of were to trace it, what's going on is here's a majority of my data. I'm having data over here to the left that's skewing it to the left. I'm having outliers to the left. We're having a kind of an unusual amount over here. This is called skewed left. Skewedness is always in the direction of the outlier. So I know we have a lot of data to the right here, but the tail is pulling it to the left. That's where my skewedness is at. I always see people erase right after I do that. And y'all think it's the other way around. And that's what happens. People mess that up because they just follow where the majority of the data is at. But it's always where the tail is going. Okay, so here we have the tail being pulled to the right. We have outliers to the right. Okay, so that's going to be skewed right. Questions on that? Make sense? That's all you have to do with those is identify it. Now, one thing I want you to understand, this is just how it works. If there are no outliers, okay, if there's no outliers, if it's a normal distribution, if it follows a symmetric curve, then the mean is the best measure of central tendency. That's the best way to describe the center. Oh yeah, okay, so the reason the mean is usually the best way to describe center, because if it's symmetric, then your mean is literally in the center. Okay, and that's the best way to describe it, center. Now what happens is if you have outliers that skew the data, outliers really mess up the mean. Okay, it can really affect the mean. So then the mean doesn't become the best way to describe the center. What outliers do not affect is your median. So if there are outliers, then the median is the best measure of central tendency, because it's just one more number to the left and right. It's not really affecting it. It's not pulling it in any direction. And think about this: if we have like the test scores in here, and then somebody makes like a 0, well, that 0 is an outlier. Okay, that's going to really affect the class mean. But it's not going to affect the class median because that's just one more number that we're going when we're going left and right, back and forth. It's not affecting the mean. Does that make sense? Can I see what I'm saying? So, mean, when we're talking about a symmetric curve, any skewedness, we're talking about median for the central tendency. All right, questions on that? All right. So we have the measure of center. We have the measure of the shape. The very last thing we're talking about is the measure of the spread. So how the data is spread apart from each other. That can be helpful to understand. How data can either be very consistent or very inconsistent, spread apart or very close together. 3 ways to talk about that. We're only going to talk about 2 of them today. First one's range, which everybody should be familiar with the range, which cannot always be reliable. So we also have to look at something called the interquartile range. Does that ring any bells? Who remembers at least hearing that phrase at some point? Interquartile range. I abbreviate it as IQR. Okay. And the last one, which I think is the most important one, but we're going to talk about that tomorrow, is your standard deviation. Anybody here take stats? Move around? Yeah. Okay, so this should all be review, right? So those are the 2 we're talking about today. All right. The first one, range. Everybody should know range. Everybody's done range. The range is literally how our data goes from smallest to largest, right? So it's the difference between the highest and the lowest value. And that can tell us some good stuff. It can tell us how people perform, or if there's a huge gap in our data or a small gap in our data. It says Cheryl took 7 math tests in 1 semester. What is the range of her test scores? She got 89, 73, 84, 92, 87, 77, 94. They're all kind of around each other. A, B, C, they're all kind of close. What's her highest test score? 94. What's her lowest? 73. So her range of test scores is between 94 and 73. That's a range of 21. Okay, so like you can make assumptions on it based off that. You can say, oh, her range is 21, so she scores between only a couple letter grades. That's pretty consistent. But sometimes range isn't the best thing to use. Like let's say that Cheryl's having a really bad day. She comes in and she only puts her name on the test, so the teacher gives her a 3. You gotta at least give her a 3 for that. Okay. So then, what would her range be? 94 minus 3 is 91. Does this mean anything? Does 91, does that give me a good representation of her range? No, her range is more around 21. That outlier really screwed us up. Doesn't tell us much. So a range is great if there's no outliers, but if there are outliers or a lot more data points or a bigger range of data, the best way to describe spread would then be something called the interquartile range. So let's build up to that, and we'll end with that today. Okay. All right. In order to build up that, you got to know what quartiles are in order to find the interquartile range. Okay. We're going to do all this with the calculator too, so that's good. But what a quartile is it separates our data into 4 equal parts. Okay. A quartile is a number. It's a number that separates our data into 4 equal parts. What I mean is, like, if you can take 3 numbers, Q1, Q2, and Q3, and it's going to divide them into groups that have the same amount of numbers in each. So, like, if I have, if I had 20 numbers in my data set, I would have like 5 here, 5 here, 5 here, and 5 here. That's what a quartile does. It divides them into those groups. Okay. Anybody heard of a box and whisker plot? Yeah, you've done it plenty of times. That's where it's the most helpful. Okay, a box and whisker plot is designed to describe spread. That's its purpose. Okay? All right, but a quartile is a number, not a range. The smallest one, Q1 here, so Q1 or lower quartile. If I can fit this, I'll just put lower. It's the median of the lower half of the data set. So, like if I put my values in order from lowest to highest, it's the middle of the smaller data. Q2 is literally your median. Q2 is the median. It is literally the middle number. It's the one that cuts it in half. We talked about median earlier. And then the Q3 is the value that cuts it in half at the top portion. And then if you can find those three numbers successfully, you have your quartiles. Okay? So Q3 or your upper quartile. Okay? And we're going to learn later that the interquartile range is just the difference between your Q3 and your Q1. It's the difference of your middle values. And the reason we look at that more than the range is because that's where a more consistent number of your values is at. So you're going to get a better representation of your spread there. Okay. Any questions about those definitions? Okay. Like I said, those numbers are put into a box and whisker plot on a number line for us to be able to read and interpret. A box and whisker plot is going to look different depending on how much data you have in each spot. Like it could be all bunched together, it could be spread out. It's just a great tool to describe spread. But in order to create a box and whisker plot, you're going to have those 5 numbers. Your lowest value, your Q1 value, your Q2 value, your Q3, and your max. Okay? Those 5 numbers are something called it's pretty simple, a 5-number summary. So if you can identify those numbers, you can create a box and whisker plot. Okay? The rest of the class, I'm going to show you how to create a box and whisker plot, and then how to find the interquartile range, and then we'll be done. So, who remember seeing this? Any questions on this? Does it make sense? We're good? Everybody? Any issues? Okay. We'll do all this in the calculator. And whenever we do find this in the calculator, the calculator won't find the IQR, but it will create the box and whisker plot for us. If I want to find the interquartile range, which is our second measure of spread, all you have to do is literally take the range of the inner parts. Okay, so you're going to take your Q1 value and your Q3 value and subtract it. Okay, so IQR is the difference between the third and the first quartile. Okay, it is considered a more stable statistic than the total range. So like in this example here, your IQR is equal to, we'll guesstimate, we think Q3 is 95. No, 92. Subtract, we think Q1 is, I'll take it. Why do we pick hard numbers? 55, 75, is that 27? Okay, whatever. The interquartile range in this example would be 27. A better statistic than to say a 95 subtract a 10. That range doesn't make any sense. And on that note, I do want to talk about this point right here. What do you think that point's called? An outlier. Yeah, very good. If you ever see a dot that's not connected to the box and whisker plot, that is referred to as an outlier. ER or AR? Okay, sure. ER, AR. Does that make sense? Okay, they like to show those extreme values by not connecting it. I mean, this is still your minimum value, it's just not connected to your box. All right, questions about that spread? Let's do an example, then we'll call it. Okay. All right. So you have recently been promoted to store manager of some athletic shoe store. Cool. It is now your job to determine which size shoes you should stock the most of. Whatever. The owner of the store gives you the size of 11 athletes, and those 11 sizes are given to you right here. What I want us to be able to do is to draw a box and whisker plot, and then find the IQR given this data. That's it. This will all be done in the calculator. So, first things first, I want us to know how to find all of the data we need in the calculator. Alright, so with the red there, that tells us how to find really any number that we talked about earlier. Okay, all the numbers we talked about earlier can be found in the calculator. So maybe I'll let you write this down in a second, but for now, I'm going to do this with you. If you ever need to identify your mean, it's not asking for this, but your mean, your standard deviation, any number in the 5-number summary, it can be found in your stats book. Okay, I'll give you the steps on how to do that. Number 1, you go to Stat, over to Edit. Okay, and then number 2, you're going to enter your values into L1. Are we familiar with putting values into L1? You feel okay about that?
You put them in order.
You do not have to put them in order. So you can type them in exactly how they're shown in the problem. So don't worry about ordering. Okay. So you do that, and then steps 3. That's just where you can find the information. It says to go to Stat, over to Calc, and then go to in the blue here, 1 variable stats, 1 var stats, 1 variable statistics. It's the first one on the screen for Calc. The X bar is going to be your mean. This little symbol SX is going to represent standard deviation. And if you scroll down, you'll see the 5-number summary. And that's just an important menu to show you that information so you don't have to actually do it yourself. Okay? So we're going to do everything in red here first, and then we'll do a box and whisker plot. Okay? So take a second and try these steps. Those that are watching the video, wish I could show you, but try your best to follow these steps that I've written out. And we'll come back to it. Okay, so what we just did was we found the 5-number summary, the standard deviation, the mean, and the calculator. And now we're going to create the box and whisker plot that we found. If you ever want to find the box and whisker plot inside of the calculator, here's your steps. So I recommend pausing the video, taking a picture, writing this down, whatever you want to. These are the steps that I went through with the class just now on how to create the box and whisker plot. So, any questions on that? I'll leave it on here in a second. All right, let's draw the box and whisker plot. So, whenever you do it, it's not just draw the box and whisker plot. You gotta have like a reference. You gotta have a number line that you're comparing it with. Okay, so actually just draw it, right? Now, we're talking about shoe sizes. It's only going between like a 7 and 13, so we can do intervals of 1. But like if you're talking about test scores, like 0 to 100, maybe go up by 5, 10 or something. Just make sure you're consistent. So in this case, I'm probably going to start like 5 and go 6, 7, 8, I don't know, 9, 10, 11, 12, 13. I can keep going, but that's good. All right, whenever we did the calculator, we found our 5-number summary, right? Somebody's going to have to remind me what that was, because I can't remember. Well, those 5 numbers, min, Q1, the median, Q3, and the max. What was the minimum? 7, now 7 and 13 was the max. What was Q1? 8, median was 10. Q3 was 11. Cool. All right, now all you gotta do is plot those 5 numbers on the number line and just connect it in the shape of the box and whisker plot. If the max or min was an outlier, then you'd have to put that as a separate dot. Okay, but again, we use the calculator to identify that. So let's see, those dots were 7, 8, 10, 11, and 13. And I just draw the box and whisker. Yay. Hopefully it looks good. So the Q1 value and the Q3 values are into your box. Oops. Not D. Okay. And then there you go. Yay, box and whisker plot. If I wanted to find the IQR, what do I do again? Subtract. That's an R. That is an R. Try that again. So my Q3 was 11, and my Q1 was 8, and my IQR is 3. Okay? More consistent idea of the spread that we have. Okay? All right, so just to summarize, we talked about the center, the measure of center, the measure of shape, and the measure of spread. And we only talked about the range and IQR. We'll do standard deviation tomorrow. Okay? So make sure you can do the box and whisker plot here. Make sure you can do your IQR. You can find your 5-number summary, all that good stuff. And there's one more thing I want to say today, and I'll shut up. Just going back here, this is going to help with your homework, and it is a question on your test. Okay? So we're going to start that. Okay. Whenever we're talking about the mean and mean, like this is the number one most missed question on the test because you forget about it. It's just identification. So star this one if you need to. Just do something to recognize it, okay? We talked about if it is a symmetric curve, we use the mean to describe the center. If it is skewed, we use the median to describe center. Well, what about spread? All right, if it is a symmetric data set, what's the best way to describe the spread? Well, the standard deviation. Standard deviation and mean. I know we didn't talk about standard deviation today, but it and mean, they go together, okay? Standard deviation is affected greatly by outliers. So we do not use standard deviation to describe spread if there's outliers. The best way to describe spread in that case would be to use IQR. So median and IQR, that is your center and your spread for skewed data. Mean and standard deviation is your center and spread for symmetric data. That's how they go together. All right? Any questions, comments, concerns? Copy this down if you need it. We'll come to this tomorrow. All right.